Exercise 23 deals with the urinary system. We can see components of the urinary system in this diagram. Number one, you see the adrenal gland. It's just showing that it sits on top of the kidney. Number two is the kidney itself. Obviously, you have two of them. Number three, the ureter. This is what connects the kidney to the bladder. Essentially, it's like a tube. 4 and 5 show both the renal artery and the renal vein, because as we will see, what the kidneys are doing are actually acting as a filter. They're going to be filtering the blood, so you need to have that good blood supply to the kidneys. The number 6 is showing the pelvis, just the orientation of where all these different components are. Number 7 is the urinary bladder, and then 8 is the urethra. So we'll look at each of these components specifically, starting with the urethra. This is essentially like a tube that's going to transport the urine that's been produced and then stored in the bladder. It's going to transfer it from the bladder to the outside of the body and rid the body of it. There are 2 urinary sphincters that help control the release of the urine, and releasing the urine, we refer to this as voiding. The internal urinary sphincters are involuntary, the external are voluntary. So how long is this tube? Well, the urethra in females is only about 4 centimeters. It's relatively short. Males, it's much longer. It's 20 centimeters. It travels through the penis around, and so just one thing to keep in mind, and you'll see this on the diagram here, is that with the urethra right here in females, it's so small, there's only a short distance to go from the outside environment up into the bladder. Therefore, bladder infections are more common in females than they are in males, just because it's a shorter distance. For the males, what you're looking at here is the urethra here through the penis, back around, and then finally up into the bladder. So it's a much longer distance to travel. So therefore, urinary tract infections, specifically bladder infections, are going to be more common in females than males. You look at the bladder, like I said, that's where you're going to be storing the urine. How much can it store for an adult? On average, 500 to 600 milliliters. The trigone area is a triangular area that's at the base of the bladder. It's formed by the openings of the urethra and then the 2 ureters coming from the kidneys. The voiding of it is usually voluntary. The loss of the voluntary control is when somebody then suffers from incontinence. Now, on this diagram of the bladder, if we go right here, here are the openings, the 2 ureters that come down the back, but they open at the bottom of the bladder, and then here is the urethra. So that's the triangular area, or the trigone area of the bladder. Now remember, the bladder is composed of transitional epithelial tissue, which allows it, when it is empty, the cells will kind of stack up on each other. It looks layered, but when the bladder is full, these cells can then all stretch out, thereby giving more capacity, or allowing the bladder to have more volume, capacity to hold more urine. So they kind of slide to allow that stretching of the bladder. So where is the bladder located? As you can see in this diagram for females, this is the urinary bladder right here. Here is the uterus, which is one reason why I often tell people that when a woman is pregnant, you've got the fetus developing here in the uterus, and it's going to be pushing down on the bladder. So let a pregnant woman go in front of you in line for a bathroom. The ureters are responsible for transporting that urine that was formed in the kidneys down to the bladder for storage. How long are they? About 30 centimeters in length. And then the kidneys. The kidneys are on either side of the spine. Obviously, you have two of them. They are protected. There's a capsule that surrounds each one. There's fat. You also have the bottom of the ribs are helping to protect them. You've got a lot of your abdominal muscles that help to protect them. The right kidney is a little bit lower than the left kidney because of the liver extending down. When you look at the kidney internally, there's two different regions, what we call the cortex and the medulla. The cortex is the outermost region, the medulla is innermost region. There are what we call renal columns, so the kidney's divided into lobes by these columns. You've got pyramid, so you have a column, pyramid, alternating. And then the renal papillae, these are going to contain what's known as the collecting ducts and help drain them into the calyces. So let's look at the picture here to show all of this. So looking at the drawing of the kidney here, once again, the purpose of the kidney is to filter blood, so you're going to have a good blood supply coming in, the renal artery bringing the blood in, the renal vein removing it from the kidney. The blood's going to come in. You notice that the blood vessels start breaking down and branching further and further. Right here, you have your renal pyramids. Then these are the columns that are between the pyramids. The innermost area here is the medulla. So this entire innermost area is the medulla. The outermost area is the cortex out here. You do have this capsule, as I mentioned, that surrounds the entire kidney for protection. The papillae area, that is the little tip, if you will, of the pyramid. This little rounded tip, that's the papillae. You're going to be producing the urine. It's going to collect into this papillae area, and then from there it will move into the minor calyx, then into the major calyx, and then into this area here that is the renal pelvis, and then the urine is then going to leave out the ureter. The renal ileum, this is that area where things come into the kidney and leave the kidney. So your blood vessels, your nerves, the ureter, and also your lymphatic vessels there. The renal pelvis, that is kind of that funnel area right before the ureter where it's going to drain it down the ureter and eventually into the bladder. The nephron is considered the functional unit of the kidney. This is where you are going to be filtering the blood and actually producing the urine. Urine being the waste products. Everything you don't want to put back into the blood. The glomerulus, this is an area where you have this mass of capillaries, and this is where the first step is going to occur. This is where filtration will occur. The glomerular capsule, or the Bowman's capsule, is this capsule that surrounds those capillaries. Blood flows into that glomerulus by the afferent arteriole, and then it leaves by the efferent arteriole, and then it's going to flow through the peritibular capillaries. And that's going to be important because that's where you have a chance to put things back into the blood or remove remaining things. So what happens here, this is a nephron, the entire structure is a nephron here. I'm going to just change color so we can see this a little bit better. So what happens is you have the blood coming up through your artery, and then the afferent arteriole, and you have millions of these nephrons in the kidney, so it's not just in one place. The blood's coming in the proximal, in the afferent arteriole. So here's your glomerulus, the mass of capillaries. Blood's flowing through here, and then it's going to flow out the efferent. It's going to come down through this whole capillary structure that you see, this complex that is surrounding what we call the nephron right here. what happens in the kidneys is that as that blood is going into that glomerulus, as I just showed, in this area of the glomerulus, the first thing that's going to happen right here is filtration. What filtration is, you are removing things from the blood. You're going to remove most everything out of the blood except proteins are too big to move through here. So the proteins will stay in the blood. You remove most everything else. What you are doing, this is the first step, what you remove is going to go into this capsule area here and then start flowing down this tannish tube right here. This is known as your proximal convoluted tubule. This fluid that is produced in here, this is the beginning of producing your urine. So it has everything that you just took out of the blood. Now, as it's going through the proximal convoluted tubule, then it's going to move down here. This loop is known as the loop of Henle. And then it's going to move, that fluid's moving back up. Now you're the distal convoluted tubule, or DCT. And then eventually this fluid goes into, now you're into the collecting duct, which is going to then drain into the renal papilla, and then the minor calyx and the major calyx, then the renal pelvis, and then out the ureter. But it's in this entire nephron where you are producing the urine. Why do you have all these capillaries around here? Well, like I said, first step right here in the proximal convoluted tubule, that was the filtration. You remove everything out of the blood that you can in terms of calcium, phosphorus. You're removing some of the water depending on whether the person's dehydrated or not. Like I say, proteins cannot, under normal conditions, cannot pass into the urine here. So the blood is continuing down through these capillaries. Well, as you're producing the urine and the fluid is going down here, now you have what's known reabsorption occurring. Reabsorption is you're taking items and putting it back into the blood. How do you know? Because you're constantly monitoring the concentration of the blood. Oh, wait a minute. We need to put a little, we're kind of low in calcium. Let's put more calcium back into the blood. Don't keep it in the urine and have you pee it out, because then your calcium levels are going to drop even lower. We need to put it back into the blood right now. Now that may change in 2 hours or 10 minutes. So the body's, remember, for homeostasis, it's constantly monitoring the concentration of everything in the blood. Why? So that you know here in the kidneys, what do you keep out? What do you put back into the blood? So filtration, first step, you're taking out of the blood. Reabsorption, second step, you're putting back into the blood, where all of these capillaries that are surrounding the proximal convoluted tubule, the loop of Henle down here, and then the distal convoluted tubule. All of these capillaries in here, this is where you are putting things back into the blood. Now, secretion is then going to be, well, maybe we need to fine tune and we need to take something back out of the blood. Yeah, we need to take some more bicarbonate out or whatever. So filtration, you're removing from the blood. Reabsorption, you're putting things back into the blood. Secretion, you're taking out of the blood. And then finally, you have the production of your final urine product, and it's going to move down through the collecting duct. The renal cortex area is that outermost area of the kidney. That is where the renal corpuscle, which is the Bowman's capsule or the glomeralis capsule, and the glomerulus, that's located in the cortex. It usually contains both the proximal convoluted tubule, or the PCT, and the distal convoluted tubule, which is the DCT. Cortical nephrons have a very short loop of Henle, so all of that nephron is in the cortex. The juxtamedullary nephrons have a very long loop of Henle, and that longer loop of Henle may extend into the medulla. But most of the nephrons are in the cortex area of the kidney.